Good. GCF is greatest common factor, so we're going to be factoring out the greatest common factor in a polynomial. But before we get to factoring it out, how would we simplify something like this? This is what we've been doing for the past couple days. Distribute the 5. And remember, we're adding exponents when we distribute. So 25x squared plus 45x. And that was our answer. Okay, that's what we've been doing the past 2 days. What we're doing today is we're going to start off with something like this, and we're going to try to figure out what is the greatest common factor. So to do that, you're going to look at each term. So the 5x to the third, the 25x squared, and the 45x. What is the greatest common factor?
5.
Okay, 5 divides evenly into all 3. What about letters? Is there a letter in common? They all have an x. So we're going to divide all of these by 5x. We're going to put the 5x on the outside because that's our GCF. On the inside of our parentheses will go the result of our division. So when we divide 5 and 5, what do we get? 1. And then when we divide fractions, or sorry, divide variables, what do we do to the exponents? Subtract them. So 3 minus 1, 2, so x squared. Plus. Now it's 25 divided by 5.
5.
And then with our exponents, 2 minus 1,
1.
1, so just x. Plus, what's 45 divided by 5? And then 1 minus 1 is 0, which means that all just becomes 1, so we don't have any variables left. So what we're going to be doing is starting off with something that used to look like an answer, and our answer is going to be something that used to look like our problems. So we're just doing our distribution backwards. We're undoing it. Okay, that's all there is to factoring out a GCF, is to look for what's in common and divide it out. Okay, so let's start with number 1 and try to see what do all 3 of those have in common. Start with a number. So what number divides evenly into all 3? 4. What about letters? They all have an x. So we put what we're dividing by, our GCF, outside the parentheses. Inside the parentheses goes the result of our division. So what's 4 divided by 4? 1. And then exponents, we subtract. So we have x to the 4th. Minus. Okay, what's 24 divided by 4? 6. And then our exponents, 3 minus 1, 2. Plus. What's 8 divided by 4? 2. And what's 1 minus 1? 0. So we don't have any variables left. And there's your answer. I'm going to get to one like that. Okay, you can also always check your work or check your answer. How do you think you can check your answer? Redistribute it and see if it matches what you started with. So if we redistribute the 4x, we get what we started with, which means we know we did it correctly. So if you're ever not sure, just redistribute it and see if it matches. That way you make sure you did it correctly. Okay, what about 2? Start with the number. 3. Okay, what about letters? Just one x, or is there more than one that goes into all of them?
They all have 2.
They all have at least 2 x's. This one has 6, so it definitely has 2. This one has 4, so it definitely has 2, and this one has 2. So we're actually going to divide by 3x squared. So how to tell if it's going to be more than just 1? If they all have the same letter, take the lowest exponent. So what's the lowest number in our exponent?
2.
So that's how many x's I'm going to take out. Okay. So we write our GCF on the outside. And then we divide and put what we did get from division on the inside. So what's 9 divided by 3? And then 6 minus 2 plus 15 divided by 3, 4 minus 2, 12 divided by 3, 2 minus 2, well 0, so we don't have any x's anymore. And then again, you can always redistribute to check your answer and make sure it works. Okay, how are we doing so far? Doing okay? You doing okay, Jay?
Yeah.
You sure?
Yeah.
Positive.
99%.
Okay. Okay, next one, number 3. What do they all have in common? 7. Do they have any letters? That all of them have? No. So this is going to be one where all we can do is a number. And sometimes all you can do is a letter. So it won't always be a number and a letter. It has to be whatever they all have. So if all you have is a letter, no numbers, then you only divide by the letter. So 7 goes on the outside. 14 divided by 7 is 2. We're not changing our variables at all because we're not dividing by a variable. 35 divided by 7 and 28 divided by 7. And that would be your final answer. Does that answer your question on that?
Yeah.
Okay, so the first 3 here were all about factoring out a monomial because what we took out was just a one term, a monomial. Any questions on factoring out a monomial? Because we're going to switch it up to go to binomials, factoring out a binomial next. Okay, so if we look at number 4, resist the urge to distribute.
I just
You distributed or you resisted the urge?
distributed.
Okay, because if we look at our 2 terms, is there something that both of those terms have in common?
X plus 5.
They have this whole x plus 5. So they have a binomial in common. So we can also factor out a binomial sometimes. So just like before, we have an x plus 5. We put our GCF on the outside. And what's the result of our division on the inside? So what's x plus 5 over x plus 5? It's 1. Okay? If you want, you can think of it as they both have the exponent of 1. So what's 1 minus 1? 0. Anything to the 0 power is 1. Okay, same thing over here. So we have plus. Now what do we get when we divide this?
2x plus 1.
Well, this is 2x times 1 because this right here will give us 1, which is just 2x. And that's your answer. Okay, so again, did you follow how we got 1 here?
Yeah.
Okay, so same thing here. We have 1 minus 1 is 0. So this whole thing becomes 2x times 1.
Yeah.
And then that becomes just 2x. Okay. So we're going to do a couple more with binomials. So again, resist the urge to multiply because we're factoring here. So if you can't help yourself, that's fine. Just know you're going to get yourself into a weird situation if you multiply.
What about PEMDAS?
What about it?
Like, because you said not to do,
So PEMDAS is for simplifying. We're factoring. So we're not simplifying at the moment. So that's why we can kind of ignore PEMDAS for a little bit. All right. So what do these two have in common?
X plus 3.
They have the parentheses x plus 3. So we put our GCF on the outside. And then the result of our division on the inside. So if we have an exponent of 2 up here, and we're dividing by, we subtract them, so that'll leave us with an x plus 3 to the first, because 2 minus 1 is 1. What do we get over here?
2.
Just 2, because 1 minus 1 is 0. Anything to the 0 power is times 1, and that would be our final answer. We're not going to worry about simplifying this. We're just practicing the factoring out part. Caitlin?
Why wouldn't it be 1?
Yeah,
Like the last one, you said it was 1.
because when you do 2 minus 1.
What can I ask? Are you talking about this division or this
Yeah.
division?
No, the first one. No,
This one?
no, yeah, that one.
This one? Okay, the difference between 4 and 5, this one started off with a x plus 3 squared.
Yeah.
Over here, we just had an x plus 5 to the first. So our exponents were the same. So when we did 1 minus 1, we got 0. Anything to the 0 is 1. Here, when we subtract, we're still left with an x plus 3 to the first power. So it doesn't completely cancel out like it did in that last one. Okay, we're going to do one more. And again, we're going to resist this urge to multiply. What do the two terms have in common? X minus 2. So we put our GCF on the outside. And what do we get when we divide? So here, this is like the last one. We have an exponent of 2. Subtract 1. So, whoops, that should be a minus, not a plus. So we'll have an x minus 2 minus, and then over here, 1 minus 1 is 0. So we're left with just x plus 1. And again, we can stop there. We don't have to go any further. We're just practicing the factoring out GCF part of this. Next year, you'll learn how to go further and how to do more with it. But right now, we're just practicing this GCF part. Okay, any questions that you guys have at this point on GCF?